Good morning everyone. Terima kasih sudah bergabung di webinar ke-7 Fakultas Teknik Jurusan Teknik Kimia Universitas Negeri Semarang. Sebelumnya, perkenalkan saya, Irene Nindita sebagai host dalam seminar kali ini, serta dosen di Jurusan Teknik Kimia. Pertama-tama, mari kita panjatkan puji syukur kehadirat Tuhan Yang Maha Kuasa, karena kita telah diberikan kesehatan untuk dapat mengikuti seminar ini. Dan semoga energi positif ini dirasakan oleh semua peserta seminar. Yang saya hormati, Ibu Dr. Dewi Selvia Fardianti, STMT selaku Ketua Jurusan Teknik Kimia, Dr. Siti Wahidah selaku narasumber, Ibu Dewi Artanti selaku moderator FGD, Bapak dan Ibu dosen Teknik Kimia, dan yang saya hormati pula seluruh peserta webinar kali ini. Pada kesempatan pagi ini, topik seminar adalah tentang wastewater treatment. Baik, sebelum memulai jalannya acara, izinkan saya terlebih dahulu untuk membacakan susunan acara pada seminar kali ini. Pertama-tama, kita akan mengadakan photo session, lalu dilanjutkan dengan remarks from Head of Chemical Engineering Department, yaitu Ibu Dr. Dewi Selvia. Lalu sesi pertama yaitu wastewater treatment akan disampaikan oleh Siti Wahidah Binti Puasa PhD, dan jam 11 kita akan mengadakan Q&A session. Baik, Bapak Ibu, mari kita lanjutkan agenda selanjutnya, yaitu sambutan dari Ketua Jurusan Teknik Kimia, Ibu Dr. Dewi Selvia Fardianti. Saya persilahkan.
Terima kasih, Ibu Nindita, selaku host di acara webinar kali ini. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Selamat siang, salam sejahtera untuk kita semua. Puji syukur kehadirat Allah Subhanahu wa Ta'ala, karena di siang yang cerah ini kita bisa berkumpul secara virtual di acara webinar Jurusan Teknik Kimia Universitas Negeri Semarang. Yang terhormat, Dr. Siti Wahidah Binti Puasa dari Universiti Teknologi Mara, Malaysia. Yang terhormat Bapak Ibu dosen Teknik Kimia Universitas Negeri Semarang, Bapak Ibu dosen di lingkungan Universitas Negeri Semarang, Bapak Ibu peserta, dan juga adik-adik mahasiswa yang telah mengikuti acara webinar kami kali ini. Saya ucapkan terima kasih yang sebesar-besarnya kepada Bapak Ibu semua dan juga adik-adik mahasiswa atas partisipasinya untuk mengikuti webinar kami, dan yang secara rutin kami lakukan setiap bulan. Ada sekitar 2-3 webinar yang rutin kami lakukan setiap bulan di jurusan untuk mengisi kegiatan di era pandemi ini, karena kami semua dilaksanakan secara daring, secara online. Jadi untuk kegiatan tatap muka kami batasi, sehingga kami fokus semua kegiatan kami laksanakan secara online. Akan tetapi meskipun kita sedang dilanda pandemi, aktivitas kegiatan akademik jurusan tetap bergerak dengan mengikuti webinar-webinar, workshop, maupun focus group discussion. Begitu juga dengan mahasiswa, saya kira juga tetap aktif untuk mengikuti berbagai kegiatan ilmiah, prestasi juga mereka raih di dalam era pandemi ini. Mudah-mudahan era pandemi ini segera berakhir dan kita semua bisa berkumpul kembali secara tatap muka dan kegiatan bisa dilaksanakan seperti semula lagi, seperti sedia kala. Sekali lagi saya ucapkan terima kasih kepada Dr. Siti Wahidah Binti Puasa yang sudah meluangkan waktu untuk bersedia menjadi narasumber di kegiatan webinar kami. Dan mudah-mudahan ini bukan yang pertama kali, dan untuk kegiatan kami selanjutnya, Dr. Siti Wahidah juga berkenan untuk menjadi narasumber di kegiatan jurusan. Sekali lagi saya ucapkan terima kasih, dan juga terima kasih kepada Bapak Ibu semua. Untuk yang masuk di list kami, ini ada sekitar 200 lebih peserta, alhamdulillah. baik dari perguruan tinggi swasta maupun perguruan tinggi negeri, instansi negeri maupun instansi swasta, serta adik-adik mahasiswa dari beberapa perguruan tinggi yang mengikuti kegiatan webinar kami. Kami juga salut untuk kegiatan ini bisa diikuti oleh lebih dari 200 peserta. Selamat untuk mungkin semua pada tertarik dengan topik dari Dr. Siti. Sehingga pesertanya ini cukup banyak yang minat dari mahasiswa maupun dari luar mahasiswa. Sekali lagi saya ucapkan selamat dan webinar kami pagi hari ini, saya dengan ucapan Bismillahirrahmanirrahim, saya buka untuk webinar dengan topik Industrial Effluent Characteristic Study atau IECS yang akan disampaikan oleh Dr. Siti Wahidah Binti Puasa dari Universiti Teknologi Mara, Malaysia. Sekali lagi, saya ucapkan terima kasih dan saya tutup sambutan saya pagi hari ini dengan wassalamualaikum warahmatullahi wabarakatuh.
Ya, terima kasih atas sambutannya, Bu Selvi. Sebelum kita melanjutkan acara, saya mohon kita mengadakan foto session. Saya mohon kepada para peserta untuk membuka videonya. Baik, di sini ada 9, tapi saya persingkat mungkin 5 pertama. Saya mulai 1, 2, 3. Halaman kedua. 1, 2, 3. Halaman ke-3. 1, 2. Halaman ke-4. 1, 2, 3. Halaman ke-5. Ya, terima kasih semuanya. Kita lanjutkan lagi. Ada beberapa pengumuman yang perlu saya sampaikan. Yang pertama, akan ada link presensi yang kami bagikan di bagian kolom chat, dan para peserta dimohon untuk mengisi link tersebut. Sehingga link tersebut menjadi dasar bagi kami untuk menerbitkan e-sertifikat. Yang kedua, beberapa pertanyaan bisa dituliskan di kolom chat dan akan kami tampung untuk ditanyakan ke narasumber selama sesi tanya-jawab. Demikian pengumuman dari saya. Baiklah, agenda selanjutnya yaitu agenda presentasi materi. Sebelumnya izinkan saya untuk memperkenalkan dahulu moderator kita pada seminar kali ini. Beliau adalah Dewi Artanti Putri, STMT, sekarang sebagai Asisten Profesor di Food and Bioprocess Laboratory, Chemical Engineering Department. Moderator ini akrab dipanggil dengan Bu Tanti. Beliau adalah dosen Teknik Kimia UNNES, pembina Himpunan Profesi Mahasiswa Teknik Kimia UNNES, dan tim rintisan Pusat Unggulan Iptek Pangan Fungsional. Research area beliau yaitu di Food Processing and Additives, serta Biodegradable Products. Untuk menghemat waktu, mari kita langsung saja ke sesi selanjutnya, yaitu presentasi materi. Kepada Bu Tanti, dipersilahkan.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning and best wishes for all of us. Thank you, Ms. Nindi, as a host for the opportunity given. Praise and gratitude to Allah Subhanahu wa Ta'ala for holding this webinar. Our gratitude also goes to the Dean and the leaders of the Faculty of Engineering UNNES and also the head of the Chemical Engineering Department and lecturers of UNNES for the facilitation given on the great occasion. I'm Dewi Artanti, act as the moderator on this day. It's It is an honor for me to be given the opportunity to become a moderator for the chemical engineering webinar series with the theme wastewater treatment, especially for IECS. We welcome to our speaker to our extraordinary day, Mrs. Siti Wahidah Binti Puasa. Uh, her is Deputy Dean for Academic at Faculty of Chemical Engineering, UITM. Thank you for agreeing to be a speaker at UNNES Chemical Engineering Department webinar series. And as permission to greet our speakers. Good morning, Ms. Dr. Siti Wahidah. Welcome to our webinar.
Morning.
Morning. Next, let us greet the participants who have joined these seminars. It is recorded that 245 participants have registered for this webinar, which consists of lecturers and researchers, students, industry, and etc. Welcome to the webinar series of the UNNES Chemical Engineering Department. First, we will read the CV of Dr. Siti Wahidah. She is a senior lecturer at Faculty of Chemical Engineering, Universiti Teknologi and over 10 years experience in chemical engineering with economics, experience in research related to absorption, membrane filtration, industrial sludge, and wastewater treatment. Her recent positions are Deputy Dean for Academic, Faculty of Chemical Engineering UITM for the year of 2019 to 2021. Penyelaras latihan dan konsultasi Fakultas of Chemical Engineering UITM from the 2019 until now. Leader of Industrial Effluent Treatment System for Pilot Plant Laboratory Faculty of Chemical Engineering UITM from the 2018 until now. And her recent achievements are Best Paper Award at 6th International Conference on Science and Social Research, Anugerah Khas Jurulatih Cemerlang, 5-star EK Tier 5 Performance Score 2018, Silver Medal Invention and Innovation Design Exposition in 2019, and many more. The next, let's start the majorization with the topic is IECS in wastewater treatment. Dr. Wahidah, the floor is yours. You can share the screen now.
Okay. So, can you see my screen?
Yeah, already.
Alright.
Sudah nampak, ya.
Nampak. Okay. Assalamualaikum warahmatullahi taala wabarakatuh dan selamat pagi. Salam perkenalan semua. Saya Wahidah daripada UITM, Fakulti Kejuruteraan Kimia, Universiti Teknologi Mara. So terima kasih kerana menjemput saya untuk menghadiri sesi perkongsian berkenaan dengan sistem rawatan air seperti mana yang kita praktisnya dibuat di Malaysia, or as simply as I can say, usually in Malaysia we call it as Industrial Effluent Treatment System, IETS, or general name wastewater treatment. Okay, before we start the discussion or sharing, so I just want to highlight di UITM, di fakulti kami sendiri, kita mempunyai sistem rawatan air, or we call it Industrial Effluent Treatment System, yang digunakan untuk merawat air daripada makmal loji pandu, Pilot Plant Laboratory. So makmal itu yang kami gunakan bagi merawat air dan juga bagi tempat sebagai tempat di mana pelajar-pelajar di fakulti kami mendalami secara praktikal berkenaan dengan sistem rawatan air di peringkat industri, dan juga kami mempunyai makmal analisa berkenaan dengan sistem rawatan air. So di mana di sini juga pelajar-pelajar kami akan menjalani latihan praktikal bagaimana untuk menganalisa kualiti air. So that's how we embed all the practical skills to our students in UITM. Sekiranya dibenarkan, ada masa segala-galanya telah reda, UNNES dijemput untuk datang ke UITM untuk melihat bagaimana kami menjalankan makmal ni. Okay, alright. So before we start sharing regarding on the wastewater treatment, so before we do our design in wastewater treatment, the first thing first that we need to analyze is actually the water quality that we need to treat. For example, if you have some water from industry, from the production, main production, so the wastewater produced, you need to know the characteristic of that wastewater before you design your IETS or before you design your wastewater treatment. So therefore, we start our talk first related to the industrial effluent characteristic study. Alright, so this results or this activity is very important in Malaysia if you want to design the wastewater treatment plant. We need to have this report, and then we need to use this report to calculate the mass balance, and from this we design the size and the stability of the unit operation decided for the overall wastewater treatment. Okay. So we start with the water quality. Okay, what is the definitions of water quality? When we talk about water quality, the definitions of water quality is actually the conditions of water, including its chemical, physical, and biological characteristic. So usually with respect to suitability for particular purpose, for example, drinking, swimming, or fishing. So in Malaysia, we just share whatever that we practice in Malaysia. Okay, in Malaysia, if you have some factory, okay, so we need to consider if the water discharged from the factory after it's been treated, so where the water should go. Okay, whether air tersebut akan dilepaskan ke sungai biasa ataupun air tersebut akan dilepaskan ke sungai biasa yang melibatkan water intake, maksudnya air yang digunakan dan dirawat semula untuk kegunaan harian. So we put some standard, kita meletakkan standard-standard tertentu untuk air ini di bawah akta, sama ada kalau di Malaysia kita panggil standard A dan standard B. So dia tertakluk di bawah akta EQA 1974. Alright, so untuk kita design treatment plant kita, so perkara yang kita perlu lihat adalah karakteristik of chemical, physical, and also the biological. So contohnya, if kita nak lepaskan ke dalam kawasan yang water intake-nya akan digunakan, waternya akan digunakan sebagai water intake untuk dirawat dan digunakan semula, so the standard will be very strict lah. Okay, very strict, di mana you kena rawat air itu mencapai kualiti yang sepatutnya supaya memudahkan water treatment di bahagian water use, kegunaan harian untuk mereka rawat air itu dengan lebih mudah. Okay, so normally pure water is tasteless, colorless, and odorless. Okay, what we call it, usually we call it as universal solvent, right? When we do analysis, normally we focus we are using the standard method for the examinations of water and wastewater. Okay, we call it as AFA. Okay, this is actually the analytical procedure, standard analytical procedure that quantitatively measure the parameter and qualitatively reflects the impact of the impurities on water, right? So, and if we talk about the water pollution, it is actually defined as the presence of water impurities for certain quantities. Okay, for example, kalau kita bercerita tentang water pollution, di dalam kandungan air itu kita ada pelbagai material yang ataupun substance yang memberikan kesan kepada alam sekitar seperti highly COD concentration, highly metal concentration, and highly BOD concentration. Okay, so and also oil and grease. So these significant parameters really need to be treated before you discharge the water from the industry. So this is actually the classifications of particle contains in the wastewater. Sama ada kita akan ada dissolved particle, colloidal particle, and suspended particle. Okay. So normally, this type of particle can easily removed by using the coagulation flocculation process. Okay. All right. Impurities in water. Impurities in water, as we thought before, it is actually can be classified either suspended or dissolved form. Okay, and it caused by surface nuclei during condensation. That's natural. The most important that we need to focus is actually here, human activities, industrial and domestic wastewater, for example, from agricultural chemical. Okay, so we go directly to the wastewater categories. Okay, we have physical characteristic, okay, chemical characteristic, and biological characteristic. Normally, when you talk about physical characteristic, you can sense or you can smell it, you can see it. For example, color. Okay, color is a physical characteristic. Odor, okay, bau, itu pun adalah physical characteristic. Alright. But when you talk about chemical characteristic, for example, something that you we cannot measure, we cannot evaluate directly from our naked eyes or smell. For example, pH. So it is actually chemical characteristic. Metal, you cannot see the metal inside the water. Okay, that is a chemical characteristic. Right, and biological characteristic related to the bacteria, protozoa, for example. So we go detail on the physical characteristic. Okay, for example, we have here temperature, okay, turbidity, conductivity, solid, color, odor. So why you need to measure temperature? The purpose of measure temperature is actually for design and operation of biological treatment. So for example, you have a quite high temperature, so it will reduce the dissolved oxygen in aeration process, in biological process. So that's why you need to consider about temperature. Okay, and also turbidity, to assess the quality of treated water, especially related to drinking water, ataupun kita kata air yang nak digunakan di rumah. Jadi turbidity adalah satu parameter yang perlu dilihat dan dianalisa bagi kegunaan air di rumah. Odor, bau. Okay, especially ini pun sangat penting bagi kegunaan air di rumah. Maknanya apabila melibatkan wastewater treatment ataupun plant, okay, untuk kegunaan air di rumah, maka parameter-parameter ini perlu diambil berat. Color, warna. Okay, solid pun penting juga. Okay, kita nak minum air yang bersih. Kita tak nak minum air yang kita boleh nampak sedimen solid dekat dalam air. So solid pun adalah salah satu parameter yang sangat penting dalam penilaian water quality air. Okay, talking about temperature, normally kita akan ada apa? Alat untuk measure temperature, temperature indicator. Okay, it is a very important parameter which is effects on the chemical reaction and reaction rates, especially dalam tindak balas biological process. Okay, so ini adalah kesan daripada temperature terhadap treatment ataupun wastewater lah. Okay, algae growth higher in warm water. Okay, kalau kata temperature tinggi menggalakkan pertumbuhan algae. Affect solubility of gases in water. Macam saya kata tadi, bila temperature tinggi akan efek dissolve oksigen dalam air. So kalau kata kita ada dekat industri betul-betul, normally we provide oxygen with the help of the blower. Okay, blower akan blow udara di dalam tangki aeration. So maknanya blower perlu bekerja keras lah untuk memastikan dissolve oksigen mencukupi bagi memastikan rawatan biological process di dalam tangki itu efficient. Okay. Selain daripada itu, affect chemical reaction rate which is related to the biological process. Turbidity. Turbidity adalah measurements of light transmitting properties, maknanya kekeruhan. Kalau sekiranya air itu keruh, maka it will block the light transmitting. So turbidity akan menjadi tinggi. So biasanya dalam industrial wastewater treatment, kita tak begitu melihat on turbidity, tetapi di dalam rawatan air yang digunakan di rumah, turbidity is one of the significant parameter. Okay. So kesannya untuk turbidity, displeasing, okay, provide absorption sites on chemical and biological organism. Bila turbidity tinggi, itu bermaksud kandungan organic material banyak dalam water tersebut. Jadi dia mungkin akan provide absorption site kepada biological organism ataupun COD yang lain. Okay, normally kalau di makmal kita akan gunakan alat ini, okay, turbidity meter, untuk measure the concentrations of turbidity. Okay, normally di Malaysia kita gunakan unit NTU, inflammatory turbidity units. Okay, di mana kalau gunakan method ni dia akan screen ataupun akan calculate turbidity dalam 360 darjah. Kadang-kadang ada light transmitting tegak macam ni. 180. Ada yang 90. Untuk case NTU dia akan measure 360 keseluruhan. Okay, selain daripada tu adalah hardness, tapi yang ni related kepada concentrations of multivalent metallic cations. Selalunya hardness sumbernya adalah daripada mineral, calcium, magnesium ion in water. Okay, and some of it adalah daripada ferrum, manganese, okay, aluminium. And normally dia akan mendatangkan kesukaran lah kepada soap consumption. Color, okay, color partly due to the suspended solid ataupun directly daripada industrial waste, especially on textile, dyeing operation, food process. And color adalah salah satu parameter yang sangat mencabar untuk dirawat. Actually, it depends on the material of color itself. Okay, the structure of the color. If we talk related to the chemical engineering, we will look into the structure of color. Ada color yang mudah untuk dirawat, whereby the color is a cationic type, so dia mudah untuk dirawat. Tetapi kalau yang anionic type, very soluble, especially reactive dye, so dia sangat mencabar untuk dirawat dalam air. Okay, so of course the impact adalah color akan prevent light penetration, so dangerous to aquatic life. And organic compound reduce effectiveness of the chlorine and disinfect. Okay, color adalah organic compound, right? So itu antaranya. Dan alat yang biasa digunakan untuk color di Malaysia, so our regulation are looking on the ADMI units to measure color. Okay, so biasanya kalau di Malaysia antara alat yang boleh digunakan untuk measure color dalam unit ADMI adalah this equipment, the R6000 hack. And there are also some of the equipment or company, contohnya seperti Nagel, Merck, sekarang ni yang dah juga design alat mereka untuk measure ADMI. Okay, so untuk color, kita kena test dengan cepat. Okay, tested within 74 hours of collections because the biological and chemical changes occurring during storage may affect color. And especially bila kena cahaya, warna akan cepat berubah. So bila kita buat testing color lambat, maka the reading is not accurate. Okay. So suspended solids are particles which remains in suspension in water, either due to the motions of water because of the density of the particle is lighter than equal to the water. Okay, suspended solid ni dia suspend. Okay, dia suspend. So it's quite for us to remove the suspended solid by gravitational settling. Normally apa kita buat adalah kita akan treat dengan menggunakan coagulation and flocculation process. Okay, normally yang kita gunakan dekat industri, right? Yes, there are so many methods that we do in research. Okay, tapi di industri normally generally kita akan guna coagulation flocculation process. And it also can be organic or inorganic origin. So this is the source of suspended solid. Sometimes from the natural contaminants, from the domestic wastewater, okay, from the industrial use of water. Okay, normally kalau normally di Malaysia kita akan ada dua regulation, okay, related to water. Di bawah what we call it Department of Environment, Jabatan Alam Sekitar Malaysia. One is regulation related to industrial effluent treatment system, which is this regulation related to industrial waste water treatment, and other regulation is sewage treatment system, di mana yang ini related kepada domestic wastewater dari rumah. If you ever heard di Malaysia, we have, for example, Indah Water Consortium. Okay, satu company yang besar di Malaysia which deal with the process of treating domestic wastewater from household. So the regulation is not similar between sewage and also industrial effluent treatment system, because the nature of water, the nature of wastewater is different. Okay, industrial effluent is more on organic, some metal and also oil and grease. But normally for domestic we have mostly organic material. Okay, so the design, the type of equipment that we use to treat the wastewater is different. Alright, so impact of the suspended solid. Okay, aesthetically displeasing, provide absorption site for chemical and biological agent, and maybe degraded biologically and produce byproduct. So the use of suspended solid analysis to measure the water quality and measure several treatment process. Okay, that is for organic chemical characteristic. So we go for inorganic chemical characteristic, for example, nutrients, alkalinity, metals, cadmium, zinc, copper, okay, chlorides, sulfate, gases, and also pH. So if you look into pH, I think most of you have know how to measure the pH concentration in the wastewater. Okay, you have, this is one type of the pH pH sensor, pH equipment that we use, portable pH meter that we use to measure pH. And normally we use the portable pH meter so that it is easy for us to go to the site, and then we can do it during our consultation. And also in our lab, we also have the pH for benchtop pH that is more on research. But for consultation, we usually use portable pH meter. It is easy for us to move. Okay, wastewater with the extreme concentrations of hydrogen ion is difficult to treat by the biological means. Yes, for example, when have extreme concentrations of hydrogen ion, it relate to acidic. Okay, it's very acidic, so you have to adjust the pH first to 7 before you introduce this wastewater to the biological process. Otherwise, it will affect your bacteria. in your biological process. Metals. This is very challenging parameter to treat in the IPS or wastewater treatment. Okay, plant. All metals are soluble to some extent. Excessive amount may present health hazard. Okay, so toxic metal is actually very harmful, although at the very minimal concentration. For example, mercury. Although it's at very minimal concentration, it is actually toxic. Okay, source, the solution from natural. Okay, and the one that we need to control is actually discharge from industrial and agricultural wastewater. So the industrial. And normally we can measure the concentrations of metal by using AAS, atomic absorption spectrometry, or calorimeter, or ICP. Okay, if you are using alpha method, probably you can use AAS and also ICP. But for us, normally, because we are always have consultation at plant, okay, ITS, so we are using calorimeter, handy calorimeter. Okay, we bring to the site and then we can measure the certain metal concentration. Okay, so for calorimeter, not all metal can be measured by using this equipment. Okay, there are some metal only can be used to measure this equipment. So if we are measuring certain metal that that cannot be measured by this equipment, so what we do, we bring to the lab, our lab, because our lab we have the AAS and also ICP. So this is total nutrient analysis and ammonia. So this is actually parameter that you need to control. It's quite challenge also to control, okay, to control and to treat in the ITS, right? It is actually colorless, pungent gases, and highly soluble in water. We are thinking about, okay, normally, previously when I say that ammonia dissolved in water, we call it as ammonium hydroxide, NH4+. Okay, but actually we have also ammonia as only ammonia presence in the wastewater. So that is ammonia that we need to treat and remove from the wastewater, or as simple as we can call it, our parameter is ammonical nitrogen. Okay, so this parameter also is quite challenge to be treated depending on the nature of your wastewater. Okay. So phosphorus is also one of the parameter that we need to treat. Okay, and actually phosphorus, sometimes we also use the phosphorus as nutrient, okay, in the biological process. But excess use of phosphorus also can contribute to wastewater. Okay, biological oxygen demand. Biological oxygen demand is actually the concentrations of organic material that present in the wastewater, whereby this organic material can be degraded by using bacteria. Perbezaan di antara BOD dan juga COD. Okay. BOD adalah kepekatan organik di dalam wastewater, okay, yang mana organik tersebut boleh degrade oleh bakteria, okay, boleh dirawat oleh bakteria. Okay. Normally di Malaysia kita akan gunakan dalam industri. Untuk industri biasa, normal industri, kita akan gunakan BOD 5-day BOD. Tapi untuk wastewater daripada kilang kelapa sawit berbeza sikit. Dia menggunakan law yang berbeza, okay, regulation yang berbeza. So BOD yang dilihat adalah BOD 3 untuk 3 hari. Okay, so this is BOD test procedure. So tak apa. Okay, perbezaan di antara BOD dan COD. So now it is COD. when you talk about COD, yes, COD juga adalah concentrations of oxygen used to decompose organic material. Organic material, either it can be degraded or non-biodegradable. Okay. So, kalau kata BOD tadi, organic material yang boleh biodegrade sahaja. Tapi bila COD, dia akan ambil kira organic material either degradable or non-degradable. So from theory, we know that the amount of COD is supposed to be the concentrations of COD is higher as compared to BOD. As simply as we can say that BOD is the subset of COD. So overall is COD, you have biodegradable and non-biodegradable. So this is for COD. So but for BOD, you just have only biodegradable organic material that can be treated by using bacteria. So that is the difference. The measurements of concentration, oxygen concentration for COD and also BOD is different also. For example, for BOD, we are using bacteria. Okay, we are using bacteria. So we need to have 5 days and let the bacteria degrade the organic material, and then we measure the DO before and after. But for COD, we will use the chemical, okay, calcium dichromate if I'm not mistaken. Okay, so this chemical is highly chemical yang mempunyai kadar pengoksidaan yang tinggi. So apa dia akan buat adalah dia akan reduce ataupun dia akan degrade ke semua organic material di dalam wastewater tadi tu. Okay, and then it calculate the concentration based on the oxygen consumed. So that's why kaedah untuk measure COD berbeza, whereby you need to, kalau kita normally apa kita buat, menggunakan method HAP, kita akan tambahkan 2 ml of wastewater in a vial, okay, in a vial. So then kita bakar dalam COD reactor for about 2 hours, dan kemudian kita sejukkan, and then baru kita uji dengan menggunakan calorimeter. Tapi untuk BOD kita akan ambil dalam tempoh 5 hari. So berbezalah. Okay, hasilnya COD lebih cepat untuk kita analyze berbanding dengan BOD. Okay, so the commonly oxidant in COD assay is potassium dichromate. Okay, so inilah kaedahnya. Okay, kita akan bakar dalam COD reactor for about 2 hours, and kemudian kita akan test concentration tu dengan menggunakan calorimeter. Okay. So this is a comparison between BOD and COD. So BOD measure biodegradable organics. So COD measure biodegradable and non-biodegradable organics. So BOD use the microorganism. COD use strong chemical agent. So BOD affected by toxic substance, but COD is not affected. Okay, and BOD is 5-day incubation. So COD is 2 hours. So COD is faster as compared to BOD. So for biological characteristic, we have to coliform organism and bacteria, protozoa, viruses. Okay, so now we talk, that is a water quality, okay, and water characteristic. Now we talk about the industrial effluent characterization study, IECS. So what is IECS? So it is actually to identify the quality of effluents, water quality, and it is conducted by professional. We cannot simply ask any people to do the IECS study. IECS should be conducted by professional because there is a method how to take up the samples, okay, how routine, by hours, is that composite sampling or grab sampling. So there is a method to take the samples. And normally in Malaysia, the analytical analysis only can be performed in accredited lab. Kalau di Malaysia, SAM meaning that Scheme Akreditasi Makmal Malaysia. Only this lab can do the analytical analysis and report, present the report in the certificate of analysis. Although we in university, we have our own equipment, for example, AAS, ICP. But if our lab is not accredited lab, the results is not accepted by Department of Environment. They only accept the results from analytical accredited lab. Sorry. Okay, and the analysis is conducted based on the standard method accepted by the United States of Environmental Protection Agency, EPA. So this is actually sample of certificate of analysis that we do for one of company. Okay, so this is actually the results. So this is actually what we call it a full parameter for IECS. So we have temperature, pH, COD, BOD, and from this table, as you can see, we have 4 columns: test parameter, methods, results, and standard. Okay, standard B or standard A. Okay, standard A is quite strict as compared to standard B. Alright, and before this lab give their results, okay, sebelum dia beri resultsnya, di sini dia akan tanya kita, wastewater ni akan keluar, discharge di kawasan mana. So when we say that, okay, di kawasan ni, they will look into the coordinate whether the location is falls under standard A or standard B. Then baru dia akan keluarkan results based on the locations of the industry. Okay, so this is the method that accredited lab use. For example, here AFA 255OB for temperature. For example, copper AFA 311B for copper. Okay, and this is actually the results obtained for the analysis. Okay, so as you can see, when the lab highlight or bold the concentration here, meaning that this concentration is exceed than standard concentration. So for example, here we have COD 2808, so standard B 200. So meaning that this is the parameter that we need to consider in treating our wastewater. And also BOD 5 820, and others looks like less than the standard, and the last one is color 425. So this is the results that's very important for us before we design our IEPS, Industrial Effluent Treatment System, or wastewater treatment plant. Okay, we cannot simply design because of this factory do this type of wastewater treatment and then comply. Okay, kita follow company tu. It is not like that, because the nature of wastewater tidak sama antara satu kilang dengan satu kilang yang lain. Okay. Alright, so the IECS objective is actually to determine the physical, biological, and chemical characteristics and the concentrations of the constituent in the effluent. So we have the physical, we have the biological, and we have the chemical characteristics here. And then others is actually to determine the best treatment method for the designing of industrial effluent treatment system to comply with the regulation, okay, in Malaysia, IER 2009, as stated in the Act EQA 1974. So normally this is for designing the new IEPS. Okay, so normally in industrial effluent treatment system, we will have primary treatment, secondary treatment, and tertiary treatment. So primary treatment is more focusing on the physical and chemical treatment. Secondary treatment is more focusing on biological process. And the tertiary treatment is more focusing on advanced treatment process. Okay, so the last one is to determine the effluent characteristic of industry, which at current operations and compare with them with the characteristic in the design stage. So for this objective, this is for new designing of new ITS. So for this objective, it is for upgrading the current ITS. For example, yes, the ITS is already there, but the current process in ITS is not capable enough to treat the wastewater with the new current nature of wastewater. So whereby you need to upgrade the current ITS or you need to optimize the current ITS. So what you do, you will do the IECS study, characterization study, and then you will do the calculations of the HRT, the mass balance, and then evaluate the significant parameters. And lastly, from that evaluation, then you can decide whether you can only just do the optimization only in your ITS or you need to upgrade your ITS. So that's the importance of the ICS study. Okay, so this is the steps. I just share with you the step of doing water sampling technique for ICS. Normally, you will have the equipment, sample collection, and then you need to know sample preservation and sample analysis. Normally, when we do the ICS study, we just go to the accredited lab and then we will ask them all the bottles, and this accredited lab has already prepared the preservation solution inside the bottle. So what we do, we just put the sample inside the bottle. All the preservation solution is already prepared by the lab. And then the lab also will do the sample analysis. Okay, so for example, when you do the analysis of, when you do ICS, so all the sample must be stored in the box, okay, cooling box, and then maintain the temperature about 4 degrees C, okay, not anti-freeze, okay, it's cold but not freeze, okay, and then you have bottle, different type of bottle. For example, if you are taking sample for oil and grease, so the bottle should be white. It's like that. So this is the method of sample collection. For example, grab samples and composite samples. So grab samples, you just take a single sample, you go and take a single sample and then instantaneous and then send it to the lab. But for composite samples, you will take for a certain hours. For example, from 8 a.m. to 4 p.m. Okay, you want to see the deviation or the changes on the normal hour, peak hour. Okay, so you take the sample every 1 hour, all the data every 1 hour, and then you accumulate all the samples, you homogenize, and then you put the sample in the bottle, then you send it to the lab. As for grab, you just once, sekejap je, take it specific spot, and then terus bring it to the accredited lab. So that is the difference between grab samples and composite samples. So this is how we conduct the sampling for ICS study. Okay, we take the samples and then we measure the pH and also the temperature. Okay, and then we measure about 1 liter and then we put in the bucket here. Okay, and then we homogenize, and after that then we fill in the bottle. So sample preservation and handling is very important, okay, in order to ensure that your sampling is accurate, okay, during you send the sample to the lab. So as I said before, keep composite sample cool with ice, set at less than 6 degrees C during compositing. Okay, sejuk tapi tak beku. Okay, this is the summary of preservation method for acid, for bromide, for COD, for chloride, okay, and then type of the bottle that you can use, and then sample type in what form. So this is actually, you can get it from the standard book as mentioned before. Okay, so this is a glass bottle for parameter oil and grease, and this is PE bottle for heavy metals. So, and then you can see that here. So this is for BOD bottle. Okay. So this is actually all the info related to the industrial effluent characteristic study. So after you do all the analysis, and then you can have that results, okay, to evaluate your performance of your wastewater treatment, for example, or if you are measuring the process, the water quality at the final discharge. But if you are planning to construct or to design the new industrial effluent treatment system, so you will do the ICS at the raw, point. Okay, at the raw point. So you will ask the company, okay, what is the type of water that you want to discharge in the wastewater. For example, the pipeline from the manufacturing, from the washing. So what is the line that you think to be treated in your industrial effluent treatment system? Then after that, you will get some point there, and then you mix. You will do the sampling at that point. Okay, kena ambil kira semua air yang company plan untuk hantar ke dalam industrial effluent treatment system. Kerana water quality ini dia akan mempengaruhi. Contohnya, kalau kata company kata, okay, hari ini kami hanya nak rawat air dari point ini saja. Okay, and then you do the water sampling, and then you do the study, and then you design. Tiba-tiba company kata, oh, I nak ambil air daripada tempat lain untuk hantar juga masuk di dalam treatment system tu. So the water quality tu dah berubah. Nature of wastewater telah berubah. So you need to evaluate whether your plant can treat this type of wastewater or not. Okay, otherwise nanti dia akan berlaku non-compliance kepada air yang telah dirawat. Okay, so that is the first thing that you need to know in order for you before you operate the wastewater treatment plant or industrial effluent treatment system. Another important thing that I want to share with you guys is actually how to optimize the chemical treatment in industrial effluent treatment system operation. Okay, so process optimization is actually not involving one part. Contohnya, kita selalu berfikir kita sebagai chemical engineer, jadi kita tahu proses. Jadi apabila berlaku masalah di dalam sistem rawatan air, kita menganggap bahawa dia hanyalah melibatkan proses sahaja. Okay? Jadi kita akan lebih memfokuskan kepada menyelesaikan masalah melalui proses. Sebenarnya dia melibatkan pelbagai faktor lain, bukan sekadar proses saja. Contohnya, proses optimization dia akan melibatkan chemical proses, mechanical kesesuaian pump, okay, and then jarak pump daripada kawasan treatment, dosing pump especially, dan juga human elements, maksudnya operator yang menjaga plant tersebut, okay, which all must fall in the correct range, okay, of values of the treatment system to be effective and reliable. Okay, maknanya kesemua faktor ini perlu optimize untuk memastikan sistem rawatan air kita dapat dijalankan dengan baik. Okay, misalignment of this component resulted to inefficiency of the treatment process. Walaupun kita ada proses yang bagus, walaupun kita ada equipment yang sangat bagus, tetapi kalau operator kita ataupun our engineers is not competent enough to handle the treatment process, maka di situ akan juga berlaku, ada possibility untuk berlaku non-compliance. Okay. So, the important elements for process optimization in industrial effluent treatment system. So, we have chemical, mechanical, and human. So, it relate each other. Dia berkaitan. Okay. Dia berkaitan. So, di Malaysia, setiap industri wajib ada seorang competent person. Okay, that we call it competent person yang perlu menjaga ataupun perlu ensure that the IETS operate operate in sound engineering system. Okay, maknanya dia operate dengan baik untuk memastikan treatment plant comply, okay, dengan standard. Okay, so I share with you guys the general steps for process optimization of IETS. So the first one is, apa you kena buat adalah evaluations of process parameter. Katakan, for example, you dapat satu project to optimize or to relook into one of the wastewater treatment in one industry. So apa you kena buat adalah, first, go to the site first. Kita kena pergi site dulu dan tengok dulu. Okay, don't simply judge. Oh, from this problem, we hear about this problem. Okay, we know how to solve it. No, you have to go to the plant and do the plant audit first. before you come into any conclusion, because the unit of wastewater, the non-compliance can happen with a very simple reason only. Tak perlu cost yang tinggi, you just optimize certain part and then your plant will be compliant. Ataupun after you charge everything, then you need to put some money to upgrade your plant. It depends on the results that you do lah when you do the plant audit, and also when you do some of the exercise lah, jar test and so on. Okay, so the first one, what you have to do, you evaluate the process parameter. Okay, what is the chemical use and the effluent generation from the manufacturing process? So this is quite challenge. Okay, sebab sometimes if you are the person who are working in the industry, then it should be okay sebab you bekerja dalam industri tu. But if you are consultant like us, when you go to the industry, it's a challenge for the industry to tell you actually what is the chemical use in the treatment in the manufacturing process. So what you can do is actually you just can predict, or you just can use your fundamental knowledge to analyze the plant condition based on the industrial effluent characterization study or the results from the laboratory. Okay, so that is the first thing. Second, the nature of wastewater. For example, you have a lot of various of industry. Nature of wastewater come from the electroplating company. It's not similar as compared to the food company. It's not similar as compared to the latex company, glove company. It's not similar as compared to the, for example, pharmaceutical company. Okay, semuanya tak sama. So that is another thing that you need to consider when you evaluating the plant. And of course, the characteristic of raw wastewater, this is actually, as we said before, ICS. And what is the significant parameter? Parameter that from the raw analysis, we know that this parameter is exceed the standard. For example, before this, we have COD and also BOD. So we know that this is a significant parameter that we need to focus, okay, to treat. And then effluent flow rate. Flow rate is a very important numbers that you need to know, okay, in order for you to ensure that your IETS or your wastewater treatment plant working effectively. Sometimes the challenge in dealing with some industries are the effluent flow rate is actually exceed than the design flow rate, for example. So that's how you want to ensure that your treatment is efficient. So what you have to do is you need to ask the company to reduce the flow rate, okay, to reduce the flow rate, okay, less than the design flow rate. Okay, that's the easiest way lah. Others, you need to be creative. Okay, standard limit based on IER 2009. So this is regulation in Indonesia. So if in Indonesia you have some standard limit on your water quality, so you may refer to your standard limit, your regulation. Okay, so that is the first thing. You need to evaluate the process parameter. The second, evaluate of the chemical process and equipment reliability. Okay, when you talk about chemical process, so what is the treatment type used in the industrial effluent treatment system or wastewater treatment plant? Okay, you look at the system first. Primary process. So what type of the primary process they use? For example, they have the physical oil and grease removal, and then you have the flocculation process. So basically it is at primary treatment. Secondary treatment is related to the biological process. So what type of biological process that used in that plant? For example, you have aeration process, you have SBR, or you have extended aeration, or you have now we call it as attached group, treatment filter, for example. So what type of wastewater, what type of the secondary process that used in the industry? And the last one is tertiary process. So this is advanced process. For example, you have sand filter, activated carbon filter, or some of you have membrane process. Some of you have ion exchange. So this type of unit operation, it is actually depending on the nature of wastewater that you 1, 2, 3. For example, some of the company, for example, electroplating company, purely electroplating, they don't have the secondary treatment. Generally, they will have the primary and tertiary treatment because their wastewaters not contain a lot of organic material. So most of it is metal and also metal. So they just use primary and just tertiary treatment. So that's how they design their plant. As long as their plant comply. So that is the thing that you need to consider, okay, before you are proposing the design, right? So next, equipment design and capacity. So when I talk about equipment design, it is actually relate to the effluent flow rate also. Okay, equipment conditions, whether the equipment can be functioned or not. Okay, that is the one thing. Sometimes the mixer is not function. So when the mixer is not function, the treatment cannot be completed. Okay, the reaction cannot complete. It's quite difficult for the reaction to complete. For example, in the coagulation process. So normally you have mixer, and then suddenly the mixer rosak, damage on the spot. So what is the contingency plan that you need to do? Because if you don't have mixer, the water is static, so the reaction is quite difficult to occur because dia tak mix kan, dia tak homogeneous mixing. So what we do, we just start from the compressor. Okay, kami ambil satu kabel daripada compressor masukkan dalam tangki tersebut, and then we blow air. So as long as dia ada mixing through air tadi, then dia akan okay. Okay, sebelum kita repair the mixer, right? And industrial effluent treatment system operation and maintenance procedure. So kita kena tengok yang itulah, kita kena evaluate how it is operated and then how this company do the maintenance. Okay, performance monitoring. Bagaimana company ni buat performance monitoring? Dia check tak, for example, hari ini dia check tak pump, dia check tak mixer. So dia akan ada performance monitoring activities. Dia check tak chemical, pH, to ensure that the plant work effectively. So performance monitoring is very important in operating the industrial effluent treatment system. And then next, optimizations of ITS, you need to do the process control and performance monitoring, as I said before. Okay, use the right instrumentation for the selected process parameter, and then you need to do the performance monitoring. And in Malaysia, we have our guidance document for performance monitoring from the Department of Environment. So we have to use that guideline in order for us to conduct the performance monitoring, and the DOE will check on this record. Okay, collecting sample, analyze and reporting based on DOE requirement. DOE meaning that Department of Environment, through the system OER, online effluent reporting. Online environmental reporting, sorry. Okay, so every week we will have our treatment, and every week, okay, we will send our sample, one of our sample, to the accredited lab, and then accredited lab will release the result to us, and we will report, insert all this value in this system, online environmental reporting system. So the DOE will monitor our performance of our ITS performance through the system, and they can come if they want to come anytime. Okay, and the next is optimizations of chemical treatment. So this is very important in order for you to calculate or to determine the suitable chemical that used in chemical treatment. Chemical treatment meaning that coagulation, flocculation process, proper chemical dosage, and the set of operating conditions based on the jar test. Normally we will do the optimization study in the jar test, and then the data that we get from the jar test, we will use it and set at the dosing pump at the treatment plant. Okay, there is some calculation that we need to perform based on the results from the experiment. And chemicals are prepared correctly. For example, flocculant polymers, sometimes in industry, they are using dilution. Okay, they dilute the chemicals and then they put it in the chemical dosing tank, and then the tank, the pump will be pump the chemical into the treatment tank. So when the concentrations of chemical is not properly prepared, and it is varies, okay, berubah-ubah, sekejap prepare 4%, sekejap prepare 3%, sedangkan dosing pump tadi tu kita set sama 100 ml per minute, for example, the quality of treatment akan berubah-ubah, not consistent. So itu pun akan memberikan kesan kepada treatment process. And chemical are mixed and dispersed effectively, as I said before, the functions of the mixer. And the last one is assessments of operator knowledge. Okay, so untuk optimiskan plan, you need to ensure that your operator knowledge understand or know the manufacturing process and chemistry basis, and the treatment plan process fundamentals, and the target range of the control parameters. They know that the concentrations of the final discharge should less than the standard concentration. And some of the equipment they are using the online control now, so then need to know how to monitor or to handle the control system. And then they are fast to respond on the upset condition. Macam yang saya beritahu tadi, kadang-kadang tiba-tiba mixer rosak. So what should you do? Kadang-kadang pump is not working ataupun there's no flow at one tank because of valve locking. Sludge dah banyak dalam valve tu, dalam valve. So what you have to do, you need to open the valve and then you kena keluarkan ataupun pump, you kena discharge all the sludge tu manually. So dia kena tahu nak buat benda tu semua. They should know how to do it. Okay, so optimization required when there is non-compliance at final discharge point, and also minimize the cost of the chemical. Okay, when you know that the exact value of chemical dosing, then you can minimize the cost of the chemical. Okay, have I used the 50 minutes or I exceed the 50 minutes, Dr. Dewi?
Apakah masih banyak?
I can continue and I can stop. Teruskan dan saya boleh berhenti.
Continue. You can continue.
Okay.
You can continue.
Okay, thank you. All right, so this is how we practice do our optimizations on the chemical treatment. So the first thing first, what we have to do is we need to understand the nature of wastewater. Berkali-kali saya sebut the nature of wastewater sebab this is the different as compared to other process. Sometimes we look like wastewater ni senang je. You ada 3 treatment, primary, secondary, tertiary. But the challenge is actually you will face the different nature of wastewater kerana dia adalah waste. So that is the challenge part. Okay, that is the challenge part. So the first thing, understand the nature of wastewater. Second, you have to understand the chemical treatments of IATS. Okay, for example, some of the company, they are using the continuous process. Okay, continuous process. Okay, you have coagulation, flocculation, but it is a continuous flow. Some of the company, they are using a batch process. So handling batch is not similar as compared to handling continuous process. So then, that is the thing that you need to understand. For example, if you are doing batch, tak ada masalah because you can calculate whatever yang di dalam jatas tu, you just put the values dekat dalam batch tu because it is actually senang kan sekali, sama je dia punya prinsipal dia dengan jatas. But when it come to the continuous, you do the jatas in the lab as in batch process, but you want to operate the plant, the chemical treatment in the plant as in continuous. So that is the challenge whereby you need to know how to set the dosing pump at the treatment plant by using the data that you obtain from the chemical treatment jatas process. Okay, and then optimizations of the chemical next, we do the optimizations of the chemical treatment via jar test experiment. And then the fourth is actually we do the calculations of the chemical dosage. And the last one, the evaluation of the chemical usage. So for this session, I will stop here because this one is going to be complicated. We need to do face-to-face. Okay. Okay. Now we go for the understand of the nature of wastewater. So for example here, there is any, so this is raw wastewater. So you can see that we have some sludge. Okay. Nampak partikel terapung dalam air ni. So ini air daripada raw sebelum masuk treatment lagi. Okay. So you kena tengok any presence of solid particle or any highly suspended solid and incoming wastewater. So kalau ada, macam mana you nak treat dulu sebelum you masuk dalam chemical treatment. Kalau you masuk terus dalam chemical treatment, there's a lot of problem akan berlaku kat situ. Okay. So itu benda pertama. Kedua, the pH of the raw effluent is inconsistent or consistent. Varies. Okay. Contohnya hari ni pH yang masuk pada raw adalah 5. Esoknya 6 pH. Lusanya 7 pH. So if the pH is not consistent, so it's quite difficult for us to set it's quite challenge for us to set the dosing pump. Okay. And then latest ICS. Okay, maksudnya adakah maklumat ataupun water ICS characteristic study, water characteristic study yang diberi pada you semasa buat consultation tu adalah latest ataupun itu adalah 5 tahun lepas, 3 tahun lepas. So is there any change in ICS? So depend on effluent generation side manufacturing as compared to the ICS yang dekat design stage. Mungkin masa dia buat design stage tu dia gunakan chemical A. So this is the waste produced from chemical A. Along the way, company to operate bertukar chemical B. So mungkin the quality of concentration impurities dah bertukar. So you tak boleh guna the previous ICS in order for you to advise the company, because you need to advise company based on the latest ICS. Condition dia tak sama. Okay. And then second, understand the chemical treatments of ITS. Okay. You need to understand the process flow of your chemical treatment. So this is actually overall process flow of our treatment plant in UITM. So we have the EQ, equalization tank, we have the chemical treatment, and then we have the biological process, and we have also the sand filter and carbon filter. Previously, we operate all of this unit operation, but currently, okay, due to the current concentrations of raw wastewater, so I can manage to stop the biological process, okay, whereby I just operate chemical and also the advanced treatment, and it is adequate enough to treat our water, and then we can comply with the regulation. So we can save a lot of operational costs when we stop the biological process. So the tank just operated as holding tank only. Okay, no bacteria inside the tank. All right. So understand the flow of the chemical treatment, whether it is a batch or continuous, whether it is the hydraulic retention time, and then the sequence of the treatment, whether you need to dose coagulant first, and then pH adjustment, and then flocculation, or you need to do some pH adjustment first, and then you put the coagulant, and then you do the flocculation process. So it is also affect your costs. Okay, it's the sequence of the treatment, affect the cost and also the water quality that you produce from the treatment. Operating conditions of for each treatment tank. Okay, this is very important, especially on the chemical treatment. What is the operating condition? For example, in coagulation tank, you maintain pH like 5, for example, and then pH adjustment, you dose some caustic, okay, to maintain pH like 7, and then at polymer, you want to produce the flocculant, so you dose polymer, and then the pH will be maintained like 7 and 7.2, for example. So you need to understand or you need to know the operating conditions of each of the treatment tank. The type of chemical used for the treatment process. What is the type of coagulant that you use? Ferric chloride, PAC, So that is the type of the chemical, type of the coagulant that can be used normally in Malaysia in order for you to treat the wastewater, and it depends on the nature of wastewater itself. I cannot say that PAC is better than ferric chloride. I cannot say ferric chloride is better than PAC. It depends on the nature of wastewater. So what we do normally, we will do the jar test experiment. We can predict, we can hypothesize, but we need to prove through the jar test experiment. And then next is dosing pump capacity and the concentrations of the chemical feeder in the chemical tank. This is also very important. So this is how we conduct the optimizations of the chemical treatment via jar test experiment. So the key of selecting raw wastewater, normally we analyze the worst case condition, and then normally we do the jar test analysis for 3 consecutive days, okay, to ensure that the treatment is to ensure that the changes of the different in water nature of this water. And then, or we can do the optimization study for selections of coagulant or selections of operating conditions. And we need to consider to imitate the chemical process in the industry, and we need to understand the limitations of ITS, okay, from the industry. What is the limitation? Okay, for example, the cost, okay, the space. Okay, let's say you have this solution, and this solution requires space, but the industry doesn't have the space. So your solution is not suitable for that limitation, okay, in the industry. So before you do give some advice, you need to know the limitation first. So normally when we do jar test, we need to know the reagents, apparatus, analysis equipment, the steps, and also the data analysis. So this is actually some of the chemical that we use: PAC, ferric chloride, sodium hydroxide, and apparatus, jar test, beaker, pipette, equipment, spectrophotometer, calorimeter, and methodology. So I think most of us are doing the similar thing. We do the jar test experiment to conduct the optimization study. So I think I can skip this part. Okay, so I think that's all for now. So this is actually the results for our plant. So actually from the concentration versus pH, so we can find that we produce the lower concentration at optimum condition at pH 4. So therefore we set our plant for coagulant process, we maintain at pH 4, and then after that we add some caustic or sodium hydroxide until we obtain pH 7, and then after that we add a polymer. So that's how we complete our chemical treatment process in our treatment plant. All right, thank you.
Okay, that's wonderful presentation. The next is a Q&A session, and we already collect the question from the chat. First is from Yoga at ChemEng. The question is, if the raw water in the water treatment plant contains a lot of sludge, high ions, moss, and other biological matter, and also contains lime, what coagulant should be used for the efficient process in this water treatment sector?
Okay, all right. So this is the thing that I shared with you before. Okay, so normally if you have a lot of sludge and then biological and also slime, so normally what we do is if we can remove, before we talk about the coagulant, I just share, you can remove some of the solid or sludge before you feed the water, the raw water into the chemical process. Okay, Normally, I cannot say that which one is more suitable because the thing is you need to do jar test. But normally when we are dealing with high concentrations of COD, we are using the PAC, polyaluminum chloride, normally. But sometimes ferric chloride is also work better than PAC. But normally we are using the PAC lah. We try PAC first, and then if it is not workable, and then we try to use the ferric chloride.
Okay. The next question is from Nurul Shahida Binti Aulia Syam. This is from UITM. I have a question for you, Doctor. Can you explain more about the effluent flow rate? How does the effluent flow rate affects the efficiency of wastewater treatment? Thank you, Doctor.
Okay, can I sketch here? I still share my slide, right?
Yeah.
Okay. Now, when you talk about the effluent flow rate, how does the effluent flow rate affect your treatment process? Okay, you have the flow rate here. So, and then you have the volume. Okay, the volume of the tank. All right. Normally in wastewater treatment plant, when we are designing the wastewater, we are depending on HRT, hydraulic retention time. Okay, so flow rate unit, for example, this is meter cube per hour, and then volume is like meter cube. Okay, so hydraulic retention time, it is equal to volume divided by flow rate. Okay, so for example, when I talk about the coagulation process, yes, normally in rules of thumb, they say that coagulation process is adequate enough to be operated between 2 or 3 minutes duration. Okay, you need that HRT 2 or 3 minutes. But for my case, based on the experience, normally we are tend to design coagulation process about 10 minutes or 15 minutes HRT. Okay, yeah, just put 15 minutes and then you have V and you have Q. So your volume is constant, right? Okay, your volume is constant, but your flow rate will be varies. Okay, will be varies. So let's say you introduce high volume here, as high flow rate here. So what will happen? The HRT will be decreased. When HRT will be decreased, less than our rules of thumb, normally what will happen that the operation, the chemical reaction is not orang kata apa? Tidak berlaku dengan sempurna. Okay, for example, you introduce high flow rate. Okay, katalah sini, susah nak kira lah. Katalah you kira-kira you akan dapat 5 minit. So you just allow 15 minutes of reaction occurs in the tank as compared to supposed to be 15 minutes. So adalah tak semua organic material will be reduced effectively kalau dalam tempoh 5 minit. But again, it is depending on the nature of this water. Sometimes, if you have organic material yang I'll talk in chemical chemistry sikit yang rantaiannya mudah untuk kita degrade dan dia very suspend, dia senang nak dia rantaian dia carbon dia tidak begitu complicated. It is actually easy to treat as compared to as simple as surfactant. Rantaian yang panjang, complicated or petrochemical. So for this type of nature of wastewater, it is challenge for us to treat dekat coagulation process. So you need to you need to spend a lot of time jugalah. Macam 15 minutes ni I think adequate enough lah normally bila kita buat. So that's how. And also similar dekat aeration process, any part of the wastewater kita akan bergantung dengan HRT. And if we are designing also, macam di Malaysia kita ada guideline from the DOE to design the ITS. So you need to follow the guideline and you need to ensure that the HRT is between the values that suggested in the guideline. Okay.
Maybe it's the final question or the last question because many question have already asked in the Google form that kita bagikan pada saat registrasi. Ya, participants banyak bertanya, tapi ini saya rangkum begitu ya, Dokter. This is from Desi Hikmatul, student at Chemical Engineering Department UNNES, and from Zarif Lukman from UITM. Mungkin sama aroma, maksudnya sama pertanyaannya. Does the wastewater have the potential to be converted into renewable energy? And maybe a challenge and prospect in wastewater treatment for the future. What do you think, Doctor?
Okay, I tulis satu-satu nanti takut lupa. The first one is the chances to convert into renewable energy. The second is the challenge. Challenge of?
Challenge and prospect in wastewater treatment for the future.
All right. Challenge. Okay. Treatment in the future. Okay. So I just share my opinion since I pun tak not so expert. Okay, related to renewable energy, yes. For example, we have sludge that produced from the wastewater treatment. Okay, and it depends also on the nature of wastewater. Some of the sludge contains a lot of, for example, oil. Okay, for example, from the petrochemical. So there are some of sludge that produce a lot of oil there. And then some of the study has been conducted to change the sludge to the renewable energy. Okay, so actually industries are looking into the mass of sludge that produced to something valuable. So we are also doing the research on that. But for me, I'm just focusing on producing the sludge, change the sludge to become the composting. But some of them are change the sludge into the renewable energy, and some of them change the sludge to produce, for example, tar, okay, jalan. Okay, so there are a lot of research are doing on that. But to say that it is being commercialized, mungkin ada, tapi saya tak boleh bagi contoh sebab saya tak jumpa lagi lah, tapi mungkin ada, saya tak habis study ke. Okay, bukan tak habis study, okay. Alright, the second question is the challenge prospect of wastewater treatment for the future. Okay, the challenge as we face, I can say that our challenge is the first thing first to educate our nation ataupun semua lapisan masyarakat berkenaan dengan how to protect your water, and especially as the regulation is there, the act is there, but still people are looking as simple as throwing all the waste into the river, okay, and never thinking about air ni akan mengalir ke mana, and then siapa akan menerima akibatnya, and then because of probably kepentingan sendirilah, okay, atas kepentingan sendiri. So that is the challenge to educate kita semua. So that is the first challenge. And the second thing is happen to be kalau sekiranya kita semua tak sedar kepentingan untuk menjaga water quality ni, apa yang akan berlaku adalah kita akan menghadapi krisis air pada masa akan datang. Water crisis, whereby we need to treat water yang lebih mencabar dan lebih sukar, especially with various of chemical yang boleh lepaskan, and we need to rethink everything, how to treat all these chemicals and the technologies, and then the cost. So that is another challenge lah. Okay, And you guys, as a students, I know that you are very good in research on wastewater. Okay, try to think of some ideas that can be executed to treat the water in efficient and also practical, mudah, practical, and then easy maintenance. So that is the challenge yang biasa kita hadapi dekat industri. So focus on that type of research, and then you will see that the future prospect for water treatment akan datang, akan menjadi satu perkara yang sangat penting. Okay.
Okay. Baik, Dokter. Terima kasih. Let me summary the presentation and the discussion. The summary are the suitable water treatment is depends on the nature of the raw water, and ya kita harus jaga sumber air begitu ya dokter, supaya tidak terjadi krisis air begitu. Thank you to Dr. Siti Wahidah for the wonderful presentation and discussion for all of us. Mungkin saya kembalikan kepada host Nindi. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih kepada Ibu Dewi Artanti, seminar yang sangat menarik sekali. Sekali lagi saya ucapkan juga terima kasih kepada narasumber kita, Dr. Siti Wahidah, terima kasih, yang telah memberikan ilmu-ilmu yang sangat bermanfaat. Terima kasih pula kepada Bapak Ibu dosen serta seluruh peserta webinar. Dan untuk para peserta, jangan lupa untuk mengikuti webinar series teknik kimia yang lain. Dan saya sendiri, Irene dan Nindita sebagai host, mohon maaf apabila ada kesalahan dan mewakili jurusan teknik kimia apabila ada pelayanan kami yang kurang pada seminar kali ini. Sekian, kami tutup seminar ini, semoga bermanfaat. Waalaikumsalam warahmatullahi wabarakatuh. Mungkin Ibu Selvi?
Saya boleh tak saya nak cakap sikit? Tiba-tiba.
Boleh, silakan.
Ucapkan ribuan terima kasih juga kerana telah menjemput saya untuk share some knowledge yang tak seberapa dengan semua rakan-rakan di sana. Hopefully that from this kita boleh panjang-panjangkan our collaboration related to this field, insyaAllah. And jangan serik menjemput kami lagi. We have a lot of expert juga di sini. You can ask if you want to have some session related to safety and so on. Kita pun ada juga boleh dikongsikan dengan UNNES di sana. Harap maaf kalau sekian terkasar bahasa, tersilap kata. Minta maaf banyak-banyak. Terima kasih.
Terima kasih. Thank you very much.
Terima kasih.